A metallic rod of mass per unit length 0.5 kilograms meter per second meter per inverse is lying horizontally on a smooth inclined plane, which makes an angle of 30 degree with the horizontal. The rod is not allowed to slide down by flowing a current through it when a magnetic field is of induction 0.25 T is acting on it in a vertical direction. The current flowing in the rod is keep it stationary as. Okay, so we have a rod which is lying horizontally on a smooth surface and making an angle of 30 degree. So here the rod is making the angle of 30 degree and it is lying on this surface. For example, this is the rod. So we need to tell the current flowing in the rod that is keeping it into stationary. So for that we need to remember the equilibrium equation, that is mg sin theta equal to I by b cos theta. Here g is the gravitational force, that we take it as 10 generally, and m is the mass, I is the current, and b cos theta is this angle, and for theta it is making an angle of 30 degree. We have already given that. So from that we can find the value of I, which is the current flowing in the direction and keeping the rod stationary. So for that we can find the value of as 11.32 amperes, which is this one.